Okay, guys, let's get started. My really sincere apologies. I don't know why it happened, although my calendar was showing it's a meeting time, but I assure it wouldn't happen next time. Let's get started, I guess. We need to get started.
I need a minute before we start. It's a very good thing I want to share.
Okay, sure.
Remember Salman said that our YouTube channel was being publicized in the general Omdena channel.
Yes.
So few of my friends who are working with Omdena for they have done 3-4 projects. They were so happy and excited to see the explanation that our task leads are giving and the details that they are showing. They have written, and they were asking us who is handling the overall program and all those things. So we told them it's Imran and all those things. So they was like, this is one of the perfectly executed program we have seen so far. And they have listed Philadelphia chapter in their next projects. So I'm happy that
Nice.
Good job, guys. Good job. Thank you very much for the task leads on all the participants, and of course with all our other leads, Komal and I think our marketing lead, Bilia. I mean, and all participants. A teamwork actually. Everybody has put their efforts, and that's how it's going. So it's definitely not a one-man person, one-man.
Yes, we are getting really good questions, really good suggestions. Yes. So overall, as a group, we are doing really good.
Right. It's a great teamwork, and I'm really excited for the part 2 as well. And thanks for sharing, Komal. I think it was a perfect timing. We should still get started. It's almost 9:15. It's a work day, so I know some of you will be busy. So who's first? Vardhana, I think? No, Roshni?
Roshni first.
Yes, please.
Yeah, so I'll just share my screen.
Oh, wow.
Can you see my screen?
Yes, I'm excited for you to present.
Yes, we can see.
We can.
Okay, I have just prepared one slide.
Okay, that's fine. Why? Okay.
Yeah, so
okay, that's your slide. Why don't you make it to cover your whole screen? Click on
present mode.
Yes, thank you.
Slideshow. Can you go to slideshow at the top?
I mean, there's on the bottom as well. There's a link, I think.
There is a.
Do you know where there's Zoom thing at the bottom? At the bottom, very bottom.
Yeah, at the bottom right. Yes.
Beside on the left side of it, there's a cup kind of a thing.
Yes, that cup is a present. Yes.
This one?
No, the left side. The left side.
Left to the bar, the Zoom bar.
No, left to that bar.
Left to that bar. No, go down top, bottom right.
So you can see on the bottom right, notes, comments, right? Notes and comments.
Yeah.
The third one after that.
Yes.
Fourth one after that.
Fourth one, yeah. This one, yes.
Thank you, whoever spoke.
Thank you.
Oh, it looks so good. Okay, please go ahead.
Sorry. So yeah, good morning and good evening, everyone. First of all, I'll walk you through the slide and then later take you through the code. So I have divided the steps that we have performed in data, we have done in data insight and pre-processing into all of these points. So for data insight and data accuracy, first we begin with understanding the shape of the data, that is the number of rows and columns our data set has, and then check out the head and tail of the data to understand what are the different types of feature names and their types. Then we go through different types of data types we have for each features. Identify the null values in which features we have the null values, and then summary statistics. Along with data insight and data accuracy, I think is we can accumulate it into one step only, but I have just separated it for better understanding. And then we can check the naming conventions of the features. Are they following, all of the features are following one format? Then check the data type constraints, whether we have any invalid data types for any of the features. Then validate the data also we have for each feature. Then moving on, we are checking duplicate values, whether we have any duplicate values, and if we have, we can remove them immediately. Then unique values check, where we summarize the unique values for each of the features. Basically, to understand this step basically helps us understand for categorical features what are the different types of values we have, and it will help us in deciding the encoding we want to implement. And then moving on for visual data distribution. For null values distribution, we can use missing number or heat map. I used heat map. Both works fine. And for data visualization of the entire data set, we divided into numerical features and categorical features. For numerical features, we did distribution plot, and for categorical features, we did count plot. And we can, as you can see, I have added the plots also here for missing number, heat map, distribution, and count plot. And then the last step, what we did is SweetViz installation. So it actually helped us, doing. It actually showed everything of whatever we did in first and second step in this just 2 or 3 lines of code. So it actually says the number of rows we have for the data set, the duplicate values, number of features, and then for each features, total number of missing values, unique values, and the percentage distribution of each feature. It will help us in grouping the categories for encoding of each categorical features. So yeah, that's it for the slide. I'll now move on to the code.
Yes. Deliberately, I'm asking one question. Just to expand our knowledge. Why? Can you go back to your slide?
Yeah.
In that data accuracy thing, you said there are some invalid data types. I'm deliberately asking, what are the invalid? What data are considered invalid here? Which data types are considered invalid? Like, what do you mean? Can you elaborate?
So invalid data type, we actually necessarily did not perform this step in the code, but it is a general step I added because a lot of times, we have integer values also in for string, like for categorical features, we might have some integer number also entered in the within quotes as a string, so which might be invalid. We need to go through each of the values for features to check whether we have this kind of values. For example, sometimes we have question mark also instead of null values. So this is just a general step I added. It is not a part of this process that we did for this data set.
Thank you. No, I got it.
And for this checking the feature naming conventions, I will show you. This is additional 1 line of code that I've added for it. So I'll show it in the code.
Perfect. Thank you.
If I can just add 1 line example, suppose if there is year, it cannot be a float. It has to be integer.
Yeah. For that year build also, I have added 1 additional line of code. So I will show it later. I mean, when I'm walking you through the code.
Oh.
So should I go ahead?
Yes, please. Yes, thank you.
So yeah. Starting with these are all the dependencies, that is all the libraries that we'll be using for the for different kind of function. So we will be doing. So we have imported all these libraries here. For visualization, we are using matplotlib, seaborn, and then missing number for identifying the null value distribution. And this basically is for feature selection that we'll be discussing later. First, we'll import the data set that we'll be working with, that is trained data set. And then what we're doing is we are loading the data set and putting it into a data frame, test data frame. Sorry, I'm talking about test data. I should talk about trained data. So we are working with trained data right now, trained data set right now. So we are loading the data set and assigning into trained data frame. Then next, we are looking at the shape of the data. That is how many number of rows and columns my data set has. And next, we are checking the head and tail of the data to understand how the data looks like and what are the different features we have and values we have. Okay.
Since we are recording this very quickly, since I'm assuming there are other viewers will join, or maybe some will watch later on, why we skip test data in our case? Why are you
Because
not
we are
checking it
not,
right now?
sorry, because
Why?
we are not working with test data.
Well, I guess maybe I should have asked that question. I know there were some other participant did analysis and why we actually
Oh.
just dropped that whole idea. That's okay. I think
As-
we move on for now.
As a quick comment for why we did not use the test data, the
Please.
test data that we received did not contain our target variable,
Yeah.
so it wouldn't have been valid to use as test data because we wouldn't be able to verify the accuracy of
Yeah.
any analysis that we did. So that's why we excluded the test data, and we're going to do all of our model development on the training set that has been given to us, and we will split that into a training and test set separately later in the process.
Thank you, Michael. Exactly, precisely. There may be other viewers besides these our pool on YouTube, so that's why I asked. Thank you. Good explanation. Please go ahead.
Thank you, Michael. So yeah, next we are taking a look at the different type of features we have, the data types and the null value distribution. So we have approx around 76K entries with this other different features we have in our data set and the respective data types, and we can, from this we can actually see that year built, Energy Star rating, and then a few other features down below have null values because it doesn't exactly have 75,757 records. So in addition to that, what I checked actually is all of this data features are following certain naming convention, that is they all are in upper lowercase, but this elevation feature is in uppercase. So I just went ahead and changed it into lowercase, just so that all the features should follow one naming convention. So this is one additional line of code that I have added. So from this we can actually, from this info function actually gives a lot of information, like we have 3 categorical columns, and then we have 24 float features and 37 integer features. And we'll later on we'll implement different kind of strategies to for this null features which are having null values. So yeah, and the next thing what I did is I actually, the data that we have, the buildings that are built are all in past, if I'm not wrong. So for the year built column, I just tried to check that all the year that we have should not be future dates like 2026, 2030, something like that. So I just checked if the year built column really has any year which is in future. So it looks like it doesn't have. So this is one check, data validity check that I did. Then moving on, I also checked for duplicate entries, like if our data has any duplicate entries, and it doesn't have. Next, what we did is we checked for unique values. If our data has any what are all the unique values we have for each of the features. This basically gives us an idea, basically for categorical feature, what are the different types of values we have for each features, and on that factor we can actually decide what kind of encoding we would like to use for them. So yeah. Next, for descriptive statistics, this particular function actually gives a lot of information for each of the features, starting with number of observations, values that we have for each feature, then the mean value, standard deviation value, then minimum value and maximum value, and then 25 percentile range, 50 percentile range, and 75 percentile range. This particular 25, 75% and 50%, this is quartile 1, quartile 2, and quartile 3. This particular thing has a lot to do with the IQR. I think Divya can explain this when she talks about outlier detection and all. So yeah. Next, and also another thing is ID has as many has total this 75,757 unique values. So we can actually replace the index value with ID. So we'll reduce one additional column, and also this ID thing is not contributing for calculating site UI in any way. So we can drop that column and replace our index with ID. So yeah. Next, we are calculating null values, and we are understanding the percentage of null values we have for each of the features. And for year bill column, we have lowest percentage of null values. So maybe next in EDA part, we can drop it or apply different imputation techniques. And this energy star rating, direction max wind speed, direction peak wind speed max, these features have highest number of null values. So we can determine at later part what kind of imputation techniques we can apply on them. So moving ahead, so we wanted to check the null value distribution for each of these features that has null values. So we can use missing number as well as heat map. I also used heat map. Both actually kind of gives the same result, but I think I liked the missing number is more aesthetically good, so I prefer using that. But I just tried with heat map also, so both works fine. Yeah, someone was asking any question.
No.
Yeah. So next. So next, what we did is we created a data frame with only null column, null feature values. Next, what we are doing is we want to visually explore the data. So we have divided since the data set is huge, we have divided it into two data frames. One is one that has all the numerical features, and one that has all the categorical features. So we have train cat and train now. So next, we are using a distribution plot for understanding our numerical features. This is what we have done for all the feature or numerical features. So yeah, a lot of numerical features out here. So yeah, next what we have done is we have used count plot to understand the distribution of our categorical features. For state factor, billing class, and for facility type. And we can say that states for state factor, state 6 has the highest number of data. For billing class, we have highest number of data for residential, and for facility type, we have so many different approach. I think 60 different categories, out of which most of the data is in multi-family uncategorized value. Next additional, what I did is it's just I wanted to check for state 6 how many of the buildings are commercial and residential. So it is just I just did an additional step just to check. So yes, next what we did is we did switch-based installation. So basically what we have done in the first few lines, understanding the number of rows, the number of columns for the data frame, the missing values, and for each individual features, what are the different missing values, unique values, and the percentage distribution. This particular switch-based thing does exactly the same thing. It generates an HTML file, which in turn gives this output. Let me show you. So this basically gives the number of rows, the duplicate values, RAM usage, features, what are the different features we have, categorical, numerical, for this data frame. And then for each of these features, for year factor, state factor, building class, for each of these features, what are the number of observations we have, missing values we have, if we have any, what are the different distinct unique values we have. And also it shows the percentage distribution of the data for that particular feature. For example, for facility type, we have approx 60 different values. So what it did is it showed us a percentage distribution for each of the categories, and it has also grouped all of these 60 categories down to 5 categories, showing the maximum data distribution for each of the values. So from here we can actually, it will help us to group this entire different kind of values that we have into, group down into five or maybe 2-3 categories, and it will help us in deciding what kind of encoding we want to do. So yeah, I think it's the end of it. And next we think we have outlier detection. So yeah, I think this is what I had to cover. Next we have outlier detection, and I think Divya will be covering that topic, if I'm not wrong. And if you guys have any questions, you can ask.
Any questions, anyone?
I think our opening ceremony itself is, it has set very high standards now.
Yes, it's
Work
an
very hard on the
excellent
part.
grade.
Sorry.
Her first slide was excellent. Like, I just loved it.
Yes.
Yes, it's good that we are keeping good high standards, good learning experience for all. I think we should just keep moving. We are running out of time already. Oh, do you guys want to start on join the link again? It's already half an hour has passed already.
Yeah, we can do that.
Yeah.
Shall I share my screen, Imran?
Yeah, Divya, you can go ahead.
Okay. Oh, I didn't hear anything. Can you see my screen?
Yes.
Yeah, okay. So hi, good morning and good evening, everyone. So I'm gonna show how to handle the null values in a data set. For handling the null values, there are few techniques that we can use. One of the technique is we can just drop the entire row or the entire column. So if only a few percentage of data is missing, like only 2% or 1%, then dropping the entire row wouldn't hurt the performance of the model, and it wouldn't sacrifice a lot of data. If 50% of data is missing, then if you are dropping the row, then a lot of information will be missing. So in that case, we can either go with the dropping the entire column, or we can impute with some other techniques. Even while dropping the column, we cannot just drop it. If the column gives more significant value for the for predicting the output variable, then we should not drop the column. It would be a good idea to go with the imputation techniques. There are some simple imputation techniques like mean, median, and mode. So mean and median works better for the numerical variable. What it does is it calculates the mean of all the available values in a particular feature, and it will use that value to impute the missing values in the feature. So the same is with the median as well. So instead of mean, it will use the median for imputing the value. So the mean and median, that depends on the what kind of variable we are treating. We have to impute it depending on our data set. And then mode is the best way of imputation for categorical variable. So mode is just the more frequently occurring variable. So that works good for categorical variable. And other way of imputing the data is KNN imputation. KNN imputation is that uses a machine learning algorithm. So it basically works similar to KNN model. The thing is here, it identifies the k nearest neighbors. It actually measures the distance between the all the related data points, and it will group the k neighbors and then find the mean value and use that value to impute the missing value. So in that case, our imputation method will be more accurate. And since we are using a machine learning model, this might take a little bit more time than the simple imputation methods. So that is the sacrifice here. And another one thing that I came across is a deep learning library called DataWik, which uses the deep learning models for imputing the data, it seems. So it might be much more accurate, but the same way, as I said, for the machine learning model, it takes some time complexity. This one, it takes more time. So that is the problem. And this is for our data set. So in our data set, the year bill column has 2%, around 2.5% of missing values. So for that, we can either drop the entire rows, because that wouldn't hurt our performance. And also another good way is to impute with the KNN imputation. That will also give some accurate values. So we can either go with KNN, or we can just drop the rows. And then for energy star rating, 35% of values are missing. Here we, if we see the significance of the column, this column has more significance towards the output variable. It has more correlation towards the site UI variable. So we cannot just drop the variable. It is better to impute it with the KNN imputation. And that's what we did in our approach as well. And all the other three data, the direction of wind speed, maximum wind speed, peak wind speed, and maximum wind speed, these three has high correlation, and there are a lot of missing values. The missing values are more than 50%. And if it has significance, then we can use it in the data set. But looks like only number one is repeated frequently in that data, and so that may not be more significance for this data, and it doesn't have that much correlation with the output as well. So if you want, we can just remove the columns and we can try. And if you want to try another technique, we can just use the frequency value to impute it. That means we have to impute it with 1. And days with fog, it has a little bit of correlation with the output variable. So we can use the impute it with mode, or we can just treat that the missing values are the days without fog, and we can consider it as 0, and we can impute it with 0. That's how we did it in our data set. And this is the KNN imputation that we applied in the energy star rating data column. So the distribution of the energy star rating before imputation looks like this. And after the imputation, it looks like it's kind of normally distributed, and it's kind of variable as well. So I think this might help for our further processing. And then deducting the outliers. Outliers is just an observation that is completely deviated from the other set of observations. So there are few techniques that by which we can deduct outliers. One is the standard deviation method. Another one is interquartile range method. And one more simple technique is percentile based method. So percentile based method means we can just drop out the above the 99 percentile of data and below 1 percentile of data, something like that. We can just customize looking at the data itself. And for standard deviation and IQR, so this is the diagram that shows a uniform distribution. So if you look at the uniform distribution, 99.7% of data lies in between the 3 standard deviation around the mean. So this is the mean, and this is the 3 standard deviation away from the mean, these two sides. So this is the positive side and the negative side. So 99.7 data covers in this area. So if we remove the remaining data here, it will not hurt our performance. And these things are considered as the outliers. So we can remove these data from here. Yeah, we can use this only when the data is normally distributed. If the data is skewed in one side, we cannot rely on this method. So in that cases, we can go for IQR method. In IQR method, as you can see, in this box plot shows the outliers clearly. So this is the interquartile range. So as you can see, in the box, the middle line is the median line, and Q1 is the first quartile. So it is the basically this area, interquartile range, covers 50% of data, and other 25% of data is spread over here, and other 25% of data is over here. So this box gives how variable our data is. If the box is very narrow, we can know that our data is very, the range is very low. Here, if it's decent, then the variability is good. So outliers, as you can see, the minimum here it is mentioned by 1.5 times IQR. So after this IQR range, it's multiplied by 1.5, which means we are giving some extra we are giving some extra space so that we can find the extremely different data alone from our data. So these are considered as the outliers away from Q1 minus 1.5 into IQR. So this side and this side, these can be considered as the outliers. And this 1.5, it is the standard value, but we can tweak the value. We can, if we want to just remove the extremely outlied data, then we can increase the value to 2 or 3. That depends on our data set. So there are few methods to handle the outliers. One is trimming. That means we can just remove the rows of outliers. Capping means we can just use the set a minimum value and maximum value and use that value to cap all the outliers above the maximum value and minimum value to cap all the values below the minimum. For treating the outliers as a missing value, we can just impute it by treating as a missing value, and we can just impute it basically as any other missing value. And another one technique is discretization or binning. In this case, we can just convert the whole feature from the continuous variable into discretized variable. So we can basically group it into different bins so that the outliers may belong to one different bin and it might not hurt the performance of our model as well. So what we did in our data, we have actually found a lot of outliers in floor area as well as the elevation data. So in the floor area, as you can see, we before outlier removal, the data is very skewed and it's skewed towards the right. It is not normally distributed, and that's why we use the IQR method. And in the IQR method, I think Salman used 4.5 value as a threshold, because if we use that much threshold, we will just remove only the extreme outliers, not all the data points. So we won't compromise in our model. So because sometimes the larger area buildings may also give importance to our model. That may include the hospitals and big university buildings that should be included. So only we are getting rid of the extreme outliers only. So after removing the outliers, still it has some positive skewness, but that can be standardized while doing standardization. So that shouldn't be a problem. We can try with this. And for the elevation, we tried both IQR and STD method. When we use 3 standard deviation method, there was a little bit skewness. When compared to 3 standard deviation method, this IQR method gives better results. So we stick with the IQR method. And after doing IQR method, this curve is little bit better. As you can see, the skewness is also got adjusted. It's decreased from 2 to 0. So that's why we used this one for outliers. And after this, for the temperature and all those things, there were not so many outliers. So we are not removing anything from our data. So that's what we did for our outlier detection. And that concludes my presentation. Thank you. I can't hear you, Imran. I think you are talking.
I'm saying very nice job today.
Yeah, that's really amazing. Yeah,
very organized.
Fantastic job.
Considering the time constraint, I think, do you guys want to keep it continue? Otherwise, on Sundays we usually have more time, so we can shift this remaining part on Sunday. But unless you guys want to, we can just keep it continue. Your guys' call. Because usually I prefer that we have some question answering as well.
Sunday.
What?
I think let's continue on Sunday, because I think Komal is also going to leave in 5 minutes. So no, not Komal. Sorry, my bad. Manasa is also going to leave in 5 minutes. So
Today we initially got killed those 15 minutes, right? So I'll make sure next time also that doesn't happen. So I think Sunday, let's do that.
yes.
And also for next time, I wonder, it would be great if somebody to promote enhance our more learning experience, make it more better. Maybe somebody volunteer to ask some good questions in the end once the participant present and make our concepts understanding much better. That will be helpful too. But very good job today, guys. Whoever presented today, very nice slides. And thanks a lot to our actual task leads as well. They did a great job. That's why they are able so confident. So it's a very good teamwork and really excited for Sunday. Okay, guys.
Yeah, it's been fantastic. Thanks very much, everyone.
Yeah, it was really good, Roshni and Divya. It was really amazing.
Yes, and
Thank you.
Thank you.
thank you, everyone. Thanks a lot. Thanks to all participants.
Thank you.
Let's see you on Sunday.
Thank you,
Okay.
everyone.
See you Sunday.
Thank you,
Bye bye.
guys. Thanks, bye.